Hello everyone, I'm Gay Yehill and welcome to NASA's Jet Propulsion Laboratory. After 2 decades in space, the Cassini spacecraft has reached the end of its journey at Saturn. Earlier this morning, the spacecraft made its final approach to the giant planet and plunged into Saturn's upper atmosphere, ending this extraordinary mission. But due to the time it takes for radio signals to travel almost 1 billion miles between the ring planet and Earth, the team won't have confirmation that the mission has ended until they see Cassini's signal drop away. The Deep Space Network is monitoring Cassini's signal, as you can see on this DSN Now display. It's being tracked by a 70-meter wide antenna, Antenna 43, in Canberra, Australia. Here's a live picture of the control room on the other side of the world. The DSN team in Australia is keeping a watchful eye on Cassini's final transmission. Meanwhile, it is 4 a.m. here in California. The sun is not up yet, and more than 1,500 Cassini scientists, engineers, alumni, friends, and family have gathered for this moment. The flight team is in the Cassini Mission Control Area. Others have gathered in Von Karman Auditorium here at JPL, and still more are at Caltech in Pasadena. Folks wanted to be together to share this final moment. This is a vigil, but also a celebration of a remarkable mission. This is the last hour of the last chapter of Cassini's grand finale.
A lone explorer. On a mission to reveal the grandeur of Saturn, its rings and moons. After 20 years in space, NASA's Cassini spacecraft is running out of fuel. And so, to protect moons of Saturn that could have conditions suitable for life, a spectacular end has been planned for this long-lived traveler from Earth.
5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a 1 billion-mile trek to Saturn. We have cleared the tower. Bridge program is in. Full program is in.
In 2004, following a 7-year journey through the solar system, Cassini arrived at Saturn.
The SOI burn attitude or pointing position, and light up the rockets.
The spacecraft carried a passenger, the European Huygens probe, the first human-made object to land on a world in the distant outer solar system. For over a decade, Cassini has shared the wonders of Saturn and its family of icy moons, taking us to astounding worlds where methane rivers run to a methane sea, where jets of ice and gas are blasting material into space from a liquid water ocean that might harbor the ingredients for life. And Saturn, a giant world ruled by raging storms and delicate harmonies of gravity. Now, Cassini has one last daring assignment. Cassini's grand finale is a brand new adventure. As it repeatedly braves this unexplored region, Cassini seeks new insights about the origins of the rings and the nature of the planet's interior, closer to Saturn than ever before. On the final orbit, Cassini will plunge into Saturn, fighting to keep its antenna pointed at Earth as it transmits its farewell. In the skies of Saturn, the journey ends, as Cassini becomes part of the planet itself.
Okay, let's do the numbers, the Cassini numbers. The mission has traveled nearly 5 billion miles since launch, executed 2.5 million commands, taken 453,000 plus images, discovered 6 moons, published nearly 4,000 science papers. And it's not done. Cassini is sending home data right now, right to the end. Let's take a look now and talk to Cassini Program Manager Earl Mays about this. After a lineup like that, you have to be impressed.
We are impressed. It's very impressive, and we're very proud of what we've been able to accomplish over the last 13 years at Saturn. It's been awesome.
So a lot of people are asking then, why must we end this mission this way?
Well, really, and if you think about it a little bit, you'll find out we didn't have any choice. Cassini must be disposed of properly. At some point, there are international treaties that require that we can't just leave a derelict spacecraft in orbit around a planet like Saturn, which has prebiotic moons. So we've got to do something about it. We could have sent Cassini away from Saturn, but Saturn was so compelling, so exciting, and the mission that we finally came up with is so rich scientifically that we just couldn't, we had to finish up at Saturn, not someplace else. So the mission really started about 7 years ago. We've been on this path to actually end up right where we are right now in less than an hour.
So let's talk about what's about to happen and kind of walk viewers through what to expect. But let's start with Monday and the kiss goodbye.
Okay.
Can we talk about that?
Can we bring up that first graphic? Let's see what we got here. So this is the last 22 orbits of Saturn, and every one of them is going between the rings and Saturn. Absolutely unexplored territory, fantastic science every time. And what's been also happening is that out there further away is Titan. And every now and then Titan comes by, and you're going to see it come by for one last final kiss goodbye. That was it. It was very quick. You have to, don't blink. But what happened on Monday was that Titan came by and gave Cassini one last little nudge. Took away a few tens of meters per second, slowed us down just enough so that our entry into Saturn in just a few minutes now is absolutely inevitable.
So Cassini's fate is just sealed.
Sealed. Absolutely done. There wasn't much we could have done about it before because this thing had been so wired in, but after that Titan flyby, there was absolutely nothing we can do.
So step us through what has happened over this last week then, getting ready for this moment.
Okay. Well, because Cassini is still a science machine, really most of what we've been doing is still gathering more science. And so if you look at this graphic up here, we saw there's the Titan, the kiss goodbye on September 11th, and then we turned right back around after flying by Titan, getting a lot of Titan data. We turned around, played all that data back. It's on the monitors on some of our Jedi displays. You can see those. Played back all of the data from Titan, got good views of the north of the lakes and the clouds again. Then Cassini turned back around again for its final set of science observations. And we actually did a little bit of science and a little bit of just nostalgia. We took our last picture of Enceladus, our last picture of Titan, our last picture of the rings and planet, and we took one more look at the propellers and Peggy, the little moon we discovered out in the A-ring. So there's a little bit of science, a little bit of just kind of last memento photos, and those all got played back beginning yesterday afternoon about 2:45. Cassini turned back for final call to Earth, played all those data back. They're also available on our real-time display. About 1 o'clock this morning, all that data was down on the ground. Cassini then rigged herself up for, if we go back to that timeline just for a moment.
Let's go back.
Can we go back one?
There
Yeah.
you go.
So September 15th, 1:37 down there, that last plot, we actually configured ourselves into a real-time Saturn probe. Everything that comes into the spacecraft goes right back out. So there's no delay, or as little delay as we can make, so that we actually can become an atmospheric sampling mission as we go into the planet. And then, of course, at 4:55 a.m., that's give or take there are a few seconds on that, we'll be entering into Saturn's atmosphere.
And let's advance to the next display. This is what's going to be happening within the last hour.
That's exactly right. We came in over the North Pole, just a little bit east from that perspective. Actually, it looks west here, but a little bit over the North Pole. Just before 4 o'clock this morning, we were 60 degrees north. And as you can see, that descent is very rapid. In 20 minutes from now or so, we'll be at 50 degrees north. then 12 minutes later, 40, and we'll be slowly, not slowly, very rapidly increasing. The 10-degree north latitude impact point is just about where we're going to finish up. And it's going to happen about 5 of 5 this morning, local time.
And the last 90 seconds.
The last 90 seconds, this is really where it's all going to be happening. Cassini's not going to even really notice Saturn until the last 90 seconds because it's in free fall around the gravitational body. It's doing its thing and playing everything. But between 70 and 60 seconds out from final impact, it will start to notice the atmosphere. And you can see in this graphic the very tenuous atmosphere starting to experience. Now, Cassini's been fighting the atmosphere before. As a matter of fact, for the last 5 revs, we've been doing that, and it's done very well. But this time, because we're going to go in so deep, there's not a chance that it can fight to hold on to the atmosphere. That atmosphere where we've been fighting it so far is about the same density as the atmosphere that the International Space Station experiences here on Earth. Very thin, but we're going very, very fast. Oh.
All right, and we had the animation from the video earlier that sort of helps us envision, although it might be painful to watch.
It's actually, what you're watching this Valiant spacecraft, you can see the thrusters coming out active back as it starts to encounter the atmosphere. Those are small thrusters, okay? They just aren't built to fight the kind of torques. And by the way, that's the antenna, the shell trying to point at the Earth. The thrusters just aren't built to handle the kind of atmospheric torque and drag that Cassini's going to experience. But for about a minute, Cassini will hang on. We'll be sampling the atmosphere. We'll be sending the data back as quickly as we can. And then finally, of course, it's going to lose the battle. And within the next minute, we'll be completely and totally vaporized, becoming part of the planet it went to explore.
Just as planned.
As planned. Just exactly the way we've always had it to do.
And so for the team, it is bittersweet. I mean, it is sad, but there is tremendous energy here.
There is. I think we're excited because this is exactly the way we always planned this. It's sad that we're losing an incredible discovery machine. That's a loss. But what was always in the plans, and now it's working exactly the way we set it out. The images we've seen from the last few revs and the science we've had from this entire proximal orbit has just been phenomenal. So the real sense here is just, all right, we got it.
We have. What a wonderful tour.
All
right.
Thank you.
Well, thanks so much for joining us. I'll let you back in the room. I know you want to be back in there. All right. Thanks, Earl. Meanwhile, DSN 43 in Australia is the antenna locked on Cassini signal. And let's check the update display. The expected loss of signal is 4:55 a.m. And that is about 41 minutes away from now.
We've managed to inspire a younger generation of scientists, and they will continue after this is over and after the original investigators are gone to march on for their own challenges for future spacecraft exploration.
Let's look back to what inspired the mission and the day Cassini arrived at Saturn. The Cassini-Huygens mission was a joint effort of NASA, the European Space Agency, and the Italian Space Agency. It was conceived after the Voyager flybys of Saturn, and scientists all over the world insisted they had to go back.
Hello, this is Arthur Clarke, joining you from my home in Colombo, Sri Lanka. Thanks to the World Wide Web, I've been following the progress of Cassini-Huygens from the time it was launched several years ago. As you know, I have more than a passing interest in Saturn, so I'm going to keep my fingers crossed with what Cassini discovers. And who knows, one day our survival on Earth may depend on what we discover out there.
flight SOCOM.
Go ahead, SOCOM.
The Doppler has flattened out.
Okay, we have burn complete here for the SOI orbit insertion burn. For Saturn's strong gravity pulling us in, SOI burn attitude or pointing direction, and we'll hope to acquire a signal before that turn actually completes. The completion of that turn is around 7:30
Now, the voice you
local.
heard
We may pick up the
arriving,
signal from that
announcing
turn
the
from my
arrival
former
of
student,
Saturn,
Mike
June
Fink,
30th,
a couple hundred
2004,
miles
was the
above
voice
Earth
of
orbit.
Cassini
Radio, Mike.
propulsion engineer Todd Barber. Todd served as the team's commentator, and Todd is back today, once again serving as our team commentator in the same mission control room for a much different event. How does it feel, Todd, to be here?
Hi, Gay. Well, it's great to be back. It's kind of cruel to age 13 years in 2 seconds and have to watch that. But what a demonstration of the longevity of this mission. As you and I sat there in 2004, we never dreamt we'd be here in 2017 still talking about Cassini and collecting science data. So I'm just thrilled to be here, even having aged some years since SOI.
Well, Todd, very quickly, we're a couple of minutes behind here. Explain to us why the team has gathered here, even though you had told me that the spacecraft met its fate probably about 3:30 Pacific time out at Saturn, but yet the team is waiting here now and holding vigil. Why is that?
Well, it's that pesky Albert Einstein and his speed of light speed limit, 186,000 miles per second or 300,000 kilometers per second. So Saturn is about an hour and 23 minutes away from us right now, one-way light time. I'm a big sports nut. I tape a lot of games and DVR them, and the game is still exciting if you don't know the result and you haven't seen it. And no one's seen the Cassini last bits of science come back from Saturn yet. It's just about to cross the orbit of Jupiter. There's our graphic. And of course, Jupiter's in a little different position. So any denizens of the solar system at Jupiter or Mars, they'll know Cassini's fate and last bit of data before we will on Earth. So we're holding vigil here. We also have this display, kind of like a gauges in your car. This is the speed. Notice it's 63,000 miles per hour and climbing as we descend into Saturn's gravity well. And on the right side is the distance from the cloud tops, and that's just shrinking. It's going to head down over the next 37 minutes until we reach those cloud tops and say goodbye to our beautiful spacecraft out at Saturn.
And Todd, help us understand how the team will be monitoring this.
Yes, we've got a few ways. There's a display from, well, here's our radio signals. So this is the carrier frequency, and what I'd like to point out here, the peak in the middle, this is like the loudness or the signal strength, and at the Cassini frequency that it's talking. We have two displays, by the way, X-band and S-band. Those are just two different radio frequencies. So if you think in your car radio of tuning to different frequencies, that's like moving along the X-axis there, the horizontal axis. And we're getting a nice, big, strong, booming signal from Cassini on both those axes. But as we come into the atmosphere and turn away from Earth, our thrusters can't keep up anymore with the torques. Those will flatline, and that's when we say goodbye to Cassini. However, the key is to keep the data coming down to Earth and get those precious last few bits of science data from Saturn, our first sniff of the upper Saturn's atmosphere. And boy, we're excited for that.
All right. Well, thanks, Todd. We will check back with you later. And one of the signals Todd showed you is part of a computer visualization tool we call Eyes on the Solar System. This JPL computer simulation software is based on real data from missions, and it's something you can download onto your own computer and use to follow along this morning. Just go to eyes.nasa.gov, download the app, and click on Cassini's tour. Here are two family photos we'd like to share. The top one was taken on June 21st, 2017. It's the Cassini team and alumni, and they filled the staircase on the mall here. Most of them are engineers. On the bottom photo was, and this one was just taken just a few days ago, it's the science team, and they were at Caltech. The team includes scientists from all over the world. Over the years, thousands of people have worked on this mission. In fact, there are so many members of the Cassini family, we couldn't fit all of them here at JPL. It's why there's a big crowd at Beckman Auditorium at Caltech in Pasadena, and that is where Cassini science team member Morgan Cable is right now. Morgan, what is it like out there?
Hi, Gay. Well, here at Caltech, you can hear it behind me, right? This is a historic moment, and I think the mood reflects that. But it's also like a family reunion. So we're here with our other fellow Cassini family members. We're seeing people we haven't seen in a long time for some cases, and it's just been wonderful to share these memories, to revel in the excitement. This is a celebration of an amazing mission and an incredible legacy.
Morgan, you're one of the scientists.
Back to you at JPL.
You're one of the scientists out there. I mean, for you, you're probably being very reflective. What was one of the highlights for you of this mission?
For me personally, the discoveries at Enceladus have really revolutionized our view of where we might find life, or at least the conditions suitable for life in not only our solar system, but the universe. We've learned now that there are places where liquid water and the other ingredients for life as we know it to exist, chemistry and energy, exist in places like Enceladus. And that's thanks to the Cassini mission, which flew through the plume of Enceladus multiple times. This means that life may not only exist in the habitable zone around other stars, but now we can start to look for places like Enceladus or Europa elsewhere in the universe and extend our search to try to find that amazing discovery of life somewhere else.
All right. Well, we will be checking back with you, Morgan, later on the show. Thanks for that report. It is about 23 minutes past the hour. You're watching live coverage marking the final moments of Cassini on NASA TV. The Deep Space Network is awaiting the loss of signal from the spacecraft from DSN Antenna 43 in Australia. And let's go to Cassini's final hour display. At this point, the spacecraft has sent us data from about the 50-degree north latitude mark, and loss of signal should be coming about 32 minutes from now. Beautiful images from Cassini. The Cassini-Huygens mission made so many historic discoveries. Think about it. The Huygens probe sent back details of an alien world on Titan, a world that appears to be very similar to Earth. It found jets spraying water, ice, and organics from the south pole of Enceladus, revealing an interior ocean where there could be life. Over and over again, the mission revealed scientific wonders about Saturn, its rings and moons, and it hasn't stopped, at least not yet. With me now is Cassini project scientist Linda Spilker. This mission was determined to send down science right down to the very end.
That's right, Gay, till the very last second.
So Earl told us just a little while ago that overnight the spacecraft sent back the last picture show, it's been called. Can you describe what those are?
Okay, well, let's go to the very first image, image A, as part of the last picture show. The first thing we did is we made a color mosaic, and these are just a couple of pictures from that mosaic. We'll stitch those together and have a beautiful image of Saturn plus the rings for the last time. If we go to image C, that's a movie of Enceladus actually setting behind the limb of Saturn.
And explain to me how the team decided to come up with this imagery and this selection.
Well, there's a lot of science in these images, so we wanted to do science. Oh, there's Enceladus setting behind the limb of Saturn, so we're saying goodbye to Enceladus and taking a last look at that particular world. And so we wanted to sort of do a survey, look at each of these key targets, collect picture postcards for our Cassini scrapbook. So these will be the last pictures that we'll put in our scrapbook. If we look at image D, that's a true color image of Titan.
Okay.
And you can see the lakes up in the north. Image F shows this in false color. There's a UV filter as part of image F, and the lakes really pop out. And you can also see that bluish haze at the edge of Titan. You know, Titan has this thick nitrogen atmosphere. We also took some pictures of the rings, Gay. If we go to image G, we're looking for propellers in this particular image, and you can just see a hint of it above that dark gap. If we go to image H, that's a blow up, and see that little two-armed propeller. It's that little bright feature just above the dark gap. There's a collection of ring particles that are large enough they're trying to open their own gap, and they create what looks like an airplane propeller. And they have fun names of aviators. If we go to image I, that was part of the sequence, we're looking at the tiny moon Daphnis. That's the Keeler gap. And you can see those crinkly edges along the gap. That's created by Daphnis, a wake, as it goes through that system. And you can see the beautiful density waves, the interaction between the rings and the satellites, also as those bright features in our last look at the propellers. And finally, image J. This is an image looking at Saturn in a place where Cassini will be entering. So one of our last views, our very last pictures of Saturn. And you can think of Cassini as basically running a marathon. For 13 years, we've been running a marathon of scientific discovery. And we're on the last lap. And so we're here today to cheer as Cassini finishes that race.
Now, many of these images and what the spacecraft will be doing right now, all of this is unknown territory. The spacecraft has never been here before.
That's right. We're flying into Saturn more deeply than we've ever flown before. We have 8 of our scientific instruments on. The key instrument is the ion and neutral mass spectrometer. Basically coming in, we've oriented the instrument to sample the atmosphere of Saturn, which it's doing right now, deeper and deeper, until on the very final second, as Cassini fights to hold attitude, it'll send back those last very valuable packets of data. And who knows how many PhD theses might be in just those final seconds of data.
Right. We will have scientists and students poring over this data for decades to come, probably.
Right. And looking at the hydrogen to helium ratio to help us understand how Saturn formed, how Saturn's evolving, and who knows what else we'll see as we go into the atmosphere.
What great science leads it, still ahead. All right. Well, Linda, thanks for joining us.
Yeah, glad to be here.
You're watching live coverage of Cassini's final hour from the Jet Propulsion Laboratory. JPL is a NASA center in La Cañada, Flint Ridge, and Pasadena, California, and managed by the California Institute of Technology. Let's check out our display. We are now about just a little under 26 minutes from the end of mission. Well, the Cassini team considers itself a family, a team that works together and plays together. And here is one example. The Cassini virtual singers, they have a knack for putting a Cassini spin on just about any show tune. And I saw Todd Barber in that group. Todd, it is a very close-knit group and a multi-generational group. I mean, some people have spent their entire careers on this mission and others are just starting their careers on Cassini. Todd Barber is standing by with one of the younger members of the team, guidance and control engineer Joni Stupik, who started her career with Cassini, right?
Yes, that's right. And I've been on since before launch, but it's so wonderful to have young engineers join the project. Welcome, Joni. And Joni is an attitude control engineer on the project. And can you explain what that means to our viewers?
Sure, absolutely. So I and my team are in charge of the orientation of the spacecraft. So we point all of the cameras and the antenna.
That's great. And you have a particularly important role this evening, right? Or this morning, I guess I should say.
Absolutely. So as Earl and Linda have both alluded to, we want to get every last possible second of information, which means our antenna needs to be pointed towards Earth for as long as we possibly can. As we enter into the atmosphere, Saturn is going to start trying to tug us away. So we want to hold the antenna as steady as we possibly can for that whole time.
And how do you do that?
We have little engines or thrusters that we use to hold us steady.
Wonderful. So that's, and basically we will lose the battle with Saturn's atmosphere.
We will. And if we go to the graphic here, we see the thrusters firing as we try and hold that antenna for as long as we can. And that will last for only about a minute until the thrusters are finally overwhelmed and we can no longer point the antenna.
Wow, that's amazing. But those precious seconds of science data are worth every thruster pulse we put on the
every second. Yeah, we're learning all about Saturn's atmosphere with all the instruments we can as we go in. So yeah, we want to point as long as we can.
So you started your career on this mission. How are you feeling tonight, knowing we have to say goodbye to our beautiful spacecraft?
It's definitely bittersweet. Yeah, I started my career. I was in high school when Cassini arrived at Saturn. So it's really exciting, and I'm really proud to have worked on such, incredible mission and be part of such a wonderful family. But it's going to be sad. I'm used to checking how the spacecraft is feeling every morning and things like that. So it'll be a little sad to not have that anymore.
I definitely agree there, and we're so grateful for your contributions and all the young engineers on the project, as well as the veterans that have been around since launch. Thank you, Joni.
Wouldn't be able to do without the veterans.
We got a few tricks up our sleeve still. So if we can head back to the radio science display and check and see, still looking good. So we have a strong X and S band signal. So as Earl mentioned, our fate is sealed. We've met our planetary protection requirement. We know we're going to impact Saturn and take care of that. The next thing that's important is to hold that signal as long as possible and get every last precious bit of science data. So far so good, Gay. Back to you.
Thanks, Todd. Thanks, Joni. It is about 33 minutes past the hour, and the estimated time of loss of signal is 4:55 a.m. Pacific. The Cassini-Huygens mission has been an epic adventure around the Saturn system. It has sent home mountains of science data, stunning images. The spacecraft performed beautifully. The mission fulfilled its goals and then some. Members say they couldn't have asked for anything more.
This is Titan Launch Control. All the systems are go.
I've worked on the Cassini project for almost 30 years, and that's an entire Saturn orbit.
The beauty of Cassini is the design. It's the largest outer planetary spacecraft ever built. 12 different instruments. The Huygens probe, built by the European Space Agency. It's just a monumental machine.
2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
We turned the Cassini cameras down to look at the rings, revealing them in a way we had never seen them before. I remember coming back to JPL early in the morning just so I could be there and watch those pictures one by one come down. And I felt like I could almost reach out and touch the rings that were right there.
We had been collaborating with the Europeans ever since launch to make sure that we had everything right for Huygens. The Huygens probe was dropped onto Titan. These are images from a billion miles away on the surface of Titan. They're boulders, they're pebbles. We're in a dry lake bed. And I still get goosebumps just talking about it.
Looking back at what we were planning to do in those first 4 years, we've gone so far beyond that.
We remapped our investigations to concentrate on the questions that Cassini raised.
2 of our instruments actually sampled the plume of Enceladus as we flew through, tasting the gas, measuring the particles in a way that we hadn't planned. Cassini has changed the paradigm of where we might look for life. That will be one of her legacies.
13 years of exploring Saturn. It really is just an awesome mission.
All right, well, joining me now is NASA Director of Planetary Science, Jim Green. Some of Cassini's greatest accomplishments came as big surprises, didn't they?
They did, absolutely. You know, one of the ones that's pretty spectacular, obviously, is Enceladus. Now, you may not really understand the importance of having a spacecraft with all kinds of instruments, including magnetometers and plasma wave instruments, but it was really discovered, the plumes, by a magnetometer. And so as the spacecraft was doing a flyby, what was happening is the plumes were being blasted out of the tiger stripes, they were being ionized, and they're loading down the field, dragging it by. And so the magnetometer saw the wave of the field in a place that they hadn't expected. And that gave a hint that something was going on and it needed to be looked at. And so then the next pass, they came up with the idea, well, let's look at it in backlight. And wow, there were the plumes. And that started then a series of new orbits and new trajectories to try to go through and taste the plumes and get even more details about what's happening at Enceladus.
And how does this discovery sort of change the way we look for life in the solar system?
Well, this is really a calling, if you will, of hey, you're going to have to come back because there's several things we know about life. One, it metabolizes. That means it takes in a liquid. It then uses that to extract energy, and then the liquid is used to extract the waste. But then it evolves, and then it also reproduces. Well, I can't measure any of those from our spacecraft other than going after the water. So once we see an area that has water, then we know that it has a possibility of being a habitable environment.
And transitioning to the other big story, also from Cassini, is another moon, Titan.
Oh yeah, Titan. What a beautiful moon this is. You know, it's bigger than the planet Mercury. Its atmosphere is actually a significant one. It's twice the pressure that we have here on Earth. It's similar in the sense that it has a lot of nitrogen. In fact, it's dominated by nitrogen. But it also has liquid on its surface, which we know now is methane. And there's a hydrological cycle of evaporation, transport, rain, and then new lakes are forming in other locations on the moon.
And that's an incredible science legacy, but Titan also helped us with an engineering legacy as well.
Oh, absolutely. The concept of using Titan to do a gravity assist, swing bys that then enable those spacecraft to get into different orbits is a fabulous concept, because while we're doing that, and here's the koosh ball, as we say, all these spectacular flybys allow us to look at Titan in detail. So from multiple flybys, we can get a global view of that moon, and we're using that same concept at Jupiter with another moon called Europa.
All right. Well, before we go, I wanted to bring up the e-book, because one of the most fantastic things about this mission has been the imagery. Could you tell us a little bit about that?
Well, we really needed to make sure that we had wonderfully described and beautifully set images that were accessible to everyone. And after 450,000 plus images, it's so hard to pick. But we were able to go back in, get 100 beautiful images or more, and videos and all kinds of.
And there's a link where if you want to get it, you can download it off the internet.
NASA.gov/ebooks.
All right. Well, Jim, thanks for joining us. Thanks for taking time for us.
My
and
pleasure.
I know you want to get back into that control room.
Absolutely.
Thank you.
Thank you.
Well, we are a little over 10 minutes away from the loss of signal, so we will be focusing our attention to the control room very soon now. But before we do, let's take a moment to chat with JPL Director Mike Watkins. So, Mike, how are you feeling?
Well, first, good morning.
Yes, very early morning.
We always tend to do these events somehow at 3 in the morning or 5 in the morning.
Why did they do that?
But, it's kind of a bittersweet event for all of us, I think. For me personally, it's more sweet than bitter because Cassini's been such a fantastic mission. But I think, one of the important things about these events is to celebrate the incredible hard work, the decades of hard work of the team that designed, built, and operated Cassini. And that's really, right, the heart of the spacecraft is really the people that worked on it and the people that have been operating it. And this is a great time to celebrate that level of dedication, that devotion, to work on something for 10, 20, 30 years. That's sort of unparalleled in human history.
So how do you think Cassini will be remembered in the science books?
Well, I'd say most of the science books, most of what we have in science books about Saturn come from Cassini. Right. So it will be long remembered. I mean, if you look at almost everything we know came from Cassini about Saturn. But I think one of the greatest legacies of a mission is not just the scientific discoveries it makes and what you learn about, but the fact that you make discoveries that are so compelling that you have to go back. And that's really the part of what makes the end of Cassini sweet, is that the discoveries are so compelling that we have to go back. We will go back and fly through the geysers of Enceladus, and we'll go back and look at Titan, because it's just the Cassini findings are they're just groundbreaking.
But the way missions are, one mission sort of sets the footsteps for the next mission. So what's coming up next after Cassini?
So one of the things we've learned about the outer solar system is how much water is there. So we used to think that most of the water was here in the inner solar system. Here on Earth, for example, the habitable zone, Goldilocks zone between Venus and Mars, where we are. We now realize that there's a lot of water in the outer solar system. So Europa, for example, the moon of Jupiter, Enceladus. And I think what you see compelling about the outer planets is to go back and look at those ocean worlds in great detail. Fly through the geysers, try to drill down through the ice, take a look at the composition of the ice. And as Jim Green noted, are these habitable places? Are these places where there could be life? And so we here at JPL and NASA, we have plans to go back to many of these ocean worlds, as many as we can. The next one up is a multiple flyby of Europa. We call Europa Clipper, where it'll be in orbit around Jupiter and fly by Europa 40 or 50 times, and taking a very close look at that ocean and from above the ice, of course, and the composition of the ice. And then later we'll make our way to the other ocean worlds.
Ocean worlds are the things to look at right now, it seems.
Absolutely. The search for life is one of the compelling threads for NASA and for the Science Mission Directorate and for JPL. We're looking for life in our solar system, and of course we're looking for life outside the solar system. We're looking for exoplanets and other Earths. But the ocean worlds look like an incredibly compelling target.
All right. Well, thank you so much, Mike, for coming by and joining us. I know all the guys want to get back in there in the
Absolutely.
control room and be there for the moment.
The last few minutes.
All right.
Thanks, Kay.
Thank you so much. You're watching live coverage of Cassini's final hour from NASA's Jet Propulsion Laboratory. JPL is located in La Cañada, Flint Ridge, and Pasadena, and managed by the California Institute of Technology. Let's take a look at our last hour display. Our display shows that we are just over 7 minutes away from the end of mission. And it's now traveling about 75,000 miles per hour. So Cassini is traveling rapidly towards its end of mission.
For all the beauty and the exotic features that we found, those are places that startle and amaze, but not a place where you can live. And I think it gives you a perspective on the Earth and what a wonderful place it is, and more impetus to perhaps take care of it.
We are getting close to time, and at the time where we should lose that signal. Folks are watching the radio science display right now, so let's go to Todd and Joni in Mission Control.
Hi, Gay. Well, 6 minutes to go till we're 6 feet under, so it's going to be hard to say goodbye here. Radio display still looks great, as we just saw on screen. Mission Control, I hear a lot of buzz in the room about the thruster cycles, because the thrusters are firing. We're still outside the atmosphere, and they're just keeping deadbands, keeping that pointing on Earth as long as possible. So things aren't too crazy yet, but once we hit that atmosphere, things happen super fast. So let's look around the room.
ACS is nominal. We're in low rate mode, and we're waiting for high rate mode transition.
Copy,
thank you.
So that was
ACS
indicated.
fault protection systems lead.
Go ahead, system lead.
Just can I get a quick subsystem status, please?
ACS fault protection is nominal.
Copy, thank you. Thermal systems lead.
Thermal devices subsystem is nominal.
Copy, thank you. Power systems lead.
Power subsystem is nominal.
Copy, thank you. System fault protection systems lead.
System fault protection is nominal. No fault protection activity.
Copy, thank you. CDS systems lead.
CDS is nominal. We have 2 frames buffered.
Copy, thank you. Telecom systems lead. Telecom is nominal. Good, SNT.
Copy, thank you. Radio science systems lead.
Radio science is nominal. Signal levels are nominal. The residual frequency is starting to increase.
Copy, thank you. Propulsion systems lead.
Pressures and temperatures are nominal. Propulsion is nominal.
Copy, thank you. Mission planning systems lead.
Mission planning is nominal.
Copy, thank you. Flight director systems lead. Everything is nominal.
Copy.
And Ace copies. Thank you, Ace.
So what we just heard was the room going around and checking all of the subsystems. So far, all of the subsystems are nominal, about 4 minutes, 3.5 to 4 minutes away from the end.
Joni, I heard a comment there that we went from low rate to high rate control. Can you comment on that?
Sure. So we have our computer that's controlling our pointing has different modes, and it's smart enough to know when we start having to fight a little harder. So we heard that the computer acknowledged that we start having to fight a little bit.
Okay, thanks. We were remarking earlier, it's incredible this entire spacecraft runs on 600 watts of power. How much power is that?
Yeah, about half a hairdryer.
Wow.
That's all we got right now.
I won't even talk about how little fuel we have left. It's about 1% plus or minus 2%. So that's one reason we're heading into Saturn's atmosphere tonight. Under 3 minutes now. We should definitely emphasize we don't know exactly when we'll lose signal. It depends on the Saturn atmosphere and how well the thrusters fight. So stay tuned.
And
radio signal looks wonderful. X-band and S-band, 2 different radio bands, still getting the signal from Cassini.
We're approaching about 10 degrees north latitude on Saturn. "3,000 miles from the cloud tops.
I remember seeing we were going to hit the atmosphere about 77,000 miles an hour. I see we're close, so. 2 minutes and counting.
Oh, we're starting to exit the
systems. This is ACS1.
Go ahead, ACS.
We're still waiting for transition to high rate mode, but it looks like we're going to start accumulating thruster on time at a higher rate now, and our attitude control error is starting to be more active.
Copy.
That means we're just starting to sense the atmosphere, right?
Yep. We can start seeing the spacecraft starting to lose the battle with the atmosphere.
Systems ACS1, we just had the transition to high rate mode, and with this we're going to start seeing thruster on time accumulating very quickly, and the deadband is going to clamp down to 0.5.52 millirad, and we are in the atmosphere.
Copy, thank you.
Roughly 1 minute to loss of signal.
Systems, this is Nav.
Go ahead, Nav.
We can confirm what AACS just told you.
Copy, thank you.
So we're just starting to see the thrusters fire more and more. Yeah, I really can.
Radio signal still holding. 30 seconds.
Systems lead, mission planning.
Go ahead, mission planning.
Spacecraft has just crossed 10 degrees north latitude, altitude 1,000 miles.
Copy, thank you.
Systems ACS1.
Go ahead.
With the additional thruster on time, we're going to also see the deadband start riding.
Copy.
Oh, yeah.
We've crossed our 0 time. We let Jamie call it.
Flight Director, ready science.
Go ahead, Flight Director.
We have lots of signal at X-ray band and zero band.
Project Manager, Flight Director.
Go ahead.
Okay, we call loss of signal, loss of X-band at call loss of signal at 115546 for the S-band, so that would be the end of the spacecraft.
That. Project Manager on FSO Quard. Maybe a trickle of telemetry left, but just heard the signal from the spacecraft is gone, and within the next 45 seconds, so will be the spacecraft. I hope you're all as deeply proud of this amazing accomplishment. Congratulations to you all. This has been an incredible mission, an incredible spacecraft, and you're all an incredible team. I'm going to call this the end of mission. Project Manager, off the net.
So just a short time ago, Julie Webster, the Space Operations Team Manager, and Program Manager Earl Mays called it the end of mission for Cassini. It came at about 4:55 as predicted. Let's go now to Beckman Auditorium and check in with Morgan Cable. She is with Cassini interdisciplinary scientist Jonathan Lunine to find out how the scientists are doing and the team is doing down there. The mission is certainly not over for them because now there will be tons of data for them to be poring over. Morgan?
That's a very good point, Gay. There's going to be lots of data to analyze for years to come. Jonathan, how are you feeling right now?
I'm actually breathing again, and I feel sad, but we felt sad the whole week. We knew this was going to happen, and Cassini performed exactly as she was supposed to, and I'll bet there's some terrific data on the ground now about Saturn's atmosphere.
I'll bet you're right. What was your favorite memory of Cassini? Well, or share a story, just anything that comes to mind.
My two favorite moments were both having to do with Titan. One was seeing the seas of Titan for the first time from the radar on Cassini, and the other was seeing the surface of Titan from the Huygens probe, sitting with 30 other people in a trailer in the middle of Germany in the middle of winter. It was cold and dark, and there were the first pictures of gullies on the surface of an alien world.
That had to just blow your mind.
It did. I was screaming. So was everyone else.
Well, I think the mood's been a little bit more somber now, but there was applause right near the end. I think this is a celebration of Cassini's life and Cassini's legacy, and we should talk a little bit about the future. What do you see next for the Saturn system?
Well, what I would like to see next for the Saturn system is that we go back there. And there's so many things that Cassini has given us in terms of a legacy to explore. Enceladus and the possibility of life, Titan and its amazing atmosphere and lakes and seas and hydrologic cycle, Saturn and the rings and the mysteries of what lies beneath the clouds. There's an awful lot that Cassini has said to us we must go back and explore.
Yeah, there's a lot left to do in the Saturn system and elsewhere in the solar system as well.
Yeah.
Well, this has been an international mission and an intergenerational mission, right? It's been such a joy for someone like me to be able to be mentored by veterans like you. In terms of following on Cassini's legacy and mentoring the next generation, what do you see in terms of next missions coming up, being able to bring in the next generation of scientists and engineers?
First of all, I'm very, very confident and optimistic about the next generation because I can see that the experts are here already. So we will be well served in the future. Of course, NASA is going back to Europa with the Europa Clipper, which is very exciting, and the Europeans are doing JUICE to the other Galilean moons, and there are a number of concepts out there for going back to Enceladus and Titan and to Saturn. We don't know if any of those are going to happen in the next few years, but we'll see. There are lots of ideas. The important point is that Cassini has got to be a jumping off point to even more exciting exploratory missions. We can't let it stop at this point. We have to keep going on. We will in the Jupiter system. We need to go back to Saturn. We need to go to Uranus and Neptune. We need to do the whole outer solar system.
We need to. The outer planets, I think one of the amazing things that Cassini has shown us is that it's not a boring, cold place. It's dynamic. It's so incredibly varied. Just the differences in the moons of Saturn alone. It inspires us to want to go back and to learn more.
Yeah, you know, 40 years ago, Voyager 1 was launched. And it was Voyager 1 and 2 that broke open the outer solar system for us, told us that this was not a cold, dead, gray place. And then Galileo and Cassini followed on and showed us what really amazing things are going on in those systems, and that there might in fact be places for life to exist in Europa and Enceladus and Titan. And I have a poem I want to read to you as well at some point. Is this a good time?
I think it's a great time.
Okay. You know, a lot has been said about Cassini already and the end of the mission, but I think that the best I can do to leave this celebration of Cassini's end is to read a bit of a poem by Swinburne, On the Verge, which was a nautical poem about death and dying, death sailing on the sea as a metaphor for death. And so I'm going to read the last few lines of it, and I've changed one of the words. It'll be obvious. Ah, but here Cassini's heart leaps, yearning toward the gloom with venturous glee. Though her pilot eye behold nor bay nor harbor, rock nor shoal, from the shore that hath no shore, beyond it set in all the sea.
That's beautiful. You had to do that, didn't you?
I did. Sorry, Morgan.
Thank you, Jonathan, for everything.
Well, Morgan, the future is in your hands and the hands of your generation, and this was a moment of transition. It was not the end. And so let's go forth and explore the solar system together.
All right. That's a beautiful sentiment. Well, with me now is NASA Associate Administrator for Science, Thomas Zurbuchen. Dr. Zurbuchen, what was your reaction being in that control room?
Well, I was just overwhelmed with just understanding how professional this team is. You know, like during the entire time, this was clearly emotional for everybody. The Lucky Peanuts were there, but there are a lot of Kleenex, and there's a lot of use of Kleenex, but everybody was so professional to the very end, and I just saw it happening. You know, it went so fast. You know, somebody was shouting out, wow, we're struggling with Z-axis, and oh, it's gone. And I just saw that team holding together till the very end. Just really, it's all about teamwork with this mission, and it showed in the last seconds.
It truly did. And your feelings about this, what sort of legacy do you think this mission leaves?
You know, I really do think it rewrote not only what we know about the outer solar system, but how we think as humans about ourselves. You know, these worlds that it found, we never knew were there, are changing how we think about life itself. And so for me, that's why it's truly a civilization scale mission, one that will stand out among other missions anywhere.
And how will it impact future ideas and future missions as we plan new things?
You know, some of the hardest questions to answer are questions like, is there life out there? And this mission really has redefined that. It will affect how we think about that question. So of course we're tackling that at NASA with a multitude of missions, looking at Mars, trying to bring samples back, but also looking at Europa, looking at these outer ocean worlds and finding these worlds all over the universe, all over our galaxy. Every, you know, there's thousands of these exoplanets, and, you know, Saturn-like, Jupiter-like kind of exoplanets that we're discovering, and we're thinking about that in a totally new way.
And so the thought is people are clamoring to go back. Will that be difficult to do, to be able to envision another mission to these places soon?
It's always very difficult, right, to do this, because these machines are so hard to invent. To go back and, for example, take the next step on Enceladus, we want to really think what that will take. Now, there's great ideas already out there, and perhaps some of these ideas will come to fruition relatively early. I don't know, but you know, we will really start thinking about this and start talking about it in the science community overall. I mean, we encourage them to really start, you know, making plans so we can create a consensus as to what direction we want to go at. Yes, we want to really go back. This is such a wonderful system. We don't want to leave it alone.
Right, and such a beautiful one. And it's affected so many people. Dr. Zurbuchen, thank you so much for sharing this moment with us. A very special one.
Thanks to the team.
Well, the Cassini-Huygens team was a multi-international team, and just a few moments from now, we will be speaking to members of ESA and OSSI about their feelings about this mission. As we told you earlier, Cassini-Huygens was a multinational endeavor from the very, very start, a partnership between NASA, the European Space Agency, and the Italian Space Agency. This is an equally proud moment for ESA and OSI, and the ESA Director of Science, Alvaro Jimenez, joins us, and the President of OSI, Roberto Battiston, are here to share this historic moment. Thank you so much for coming. Was this something that you decided you wouldn't miss it for the world?
Of course, we couldn't miss it because we knew this moment was going to come. It's a little bit sad because we wanted to delay it as much as possible and get as much science as possible, but we knew it was coming. And that sense is sad, but it's also very nice to see that we have opened the possibility for the future science also, and for the scientists to work on the data that Cassini has collected, but also as an example, and I think we have to build on this cooperation between the US and Europe in ambitious missions like this. We are very proud of having worked together, and we have to make sure that we continue this way, because together we can do much better than separate.
More. And Roberto, your feelings, I mean, to be a part of this.
I mean, it is a very historical moment, and being part of that is really something very emotionally intense. I was not there 20 years ago when this started, but I know the story of all my friends and colleagues, and Cassini demonstrated that we can do that. We can create the condition for the international collaboration, a mission which can operate for 20 years, which can learn a tremendous amount of things for the future, is one step, a gigantic step toward the future, and I really wish and hope this is not the last one, but it's only the first one of a series.
Were you surprised at how long this mission has lasted? And the amount of information and science that it has brought back?
Not so much about the length. I think we all dreamt about it, but the discoveries and what we have found in the Cassini system, in the Saturn system, are simply amazing. We were surprised by that.
And ESA's role with Huygens and working on Titan. I mean, what was the high points for you?
Well, for me, Huygens was getting to Titan. We landed there in 2005. But the whole purpose was to understand the atmosphere of Titan, to analyze the atmosphere, which is a prebiotic atmosphere full of nitrogen and methane and these kind of elements, which is what we thought that these bodies outside in the outer part of the solar system were before life could appear, and we wanted to analyze that. But then we found that we could even land. When the mission was designed, we thought we didn't know how the surface was. We didn't know if it was going to sink or land or whatever.
And it was alive for some time when it landed.
It was alive, and that was amazing, because also we could see, first, this was the furthest away landing ever of a human-made probe. But also we found a landscape totally unexpected of Titan, something similar to Earth actually, with lakes and rivers and mountains, and very appealing, but with a totally different chemical composition, a totally different world, and with the cycles of methane rather than water. But it is so interesting, it's so
but looking at it, it does look very, very familiar.
Yes.
And Roberto, let's talk about OSI's role and the high-gain antenna. So often the project relied on the high-gain antenna as protection for the rest of the spacecraft. Was that something that was planned and you thought this is a way to use the antenna?
This antenna is amazing. It's probably the most sophisticated antenna ever built for a space mission, receiving and transmitting on 4 different bands at the same time, operating for 20 years, almost continuously. So that was the core of it. But indeed, you are right. It was designed to be as a passive thermal protection system. Going to Venus, this was shielding the satellite from the intense solar radiation. And getting into the Saturn environment, it was shielding again the micrometeorite, basically measuring by the vibration on the antenna itself the amount of micrometeorite which was hitting and to use that as a protection when entering in certain location, like the space in between the annulus and the Saturn planet, which was unknown, totally unknown. And I think this is amazing, such a sophisticated instrument to be used as a thermal shield or as a micrometeorite shield, indeed.
And Cassini was such a well-made machine and served so well. I think in its entire flight, it had only safed, I think, 3 times, and that was all. But could not have done it without both Ossie and Isa. And we are so pleased that you are here and joining us.
And these are the kind of stories about space mission that we should be told, because the fact that it was smooth and perfectly designed without trouble is a tremendous, giant bonus and should be known.
Right. Well, thank you again for coming out and being with us on this very, very special day.
Thank you to you.
All right. And that video you just saw was called Cassini Inspires. It was made up of images that the public, you, sent in using some of Cassini's raw images as well as your own artwork. Thank you so much. Well, that wraps it up from here. A bittersweet day for the Cassini team, but we can't help but feel proud of the fantastic people that made these accomplishments possible these last 20 years. And about an hour from now at 6:30 a.m. Pacific, 9:30 a.m. Eastern, there will be a news briefing on Cassini's grand finale. It will be live on NASA TV and also streamed. And for more information about the mission, you can check out the URLs you see on the screen. And a little bit earlier, Jim Green told you about the e-books. Some of the most memorable gifts from Cassini are those spectacular images. An e-book of these stunning images has been made, and you can find it by going to that link you see on the screen. Well, finally, before we go, a parting look at the DSN Now image, the display you see there. Antenna 43, that's the one in Australia, is now dark. Communication with the spacecraft is now silent. Cassini is no more, but what a legacy it leaves behind. Thanks for joining us.